on our navigation formulas. Alright, so taking a look at navigation formulas for our first foray into navigation. We'll be looking at radio navigation and visual navigation techniques coming up in the next couple of lessons, but today we're looking at formulas. A lot of what we're looking at, you're probably asking yourself, why do I need to know how to do this? I've got this fancy dancy electronic device, or this thing called ForeFlight, or I got something telling me already. Why do I need to do all of these calculations? Now let me give you the simple answer first. Your knowledge exam requires you to do some of these problems. So we're preparing you for the knowledge exam in this course, so that's why we have to learn how to do these. There are some of these that we just don't do this type of problem anymore for our navigation. The FAA still wants us to have some knowledge of how to do it. We go back into the early part of aviation history, we will see that these formulas were absolutely needed to fly from point A to point B, especially when we started introducing long distance traveling. So there is a historic reference to a lot of these, and you do need to be able to do them for a knowledge exam. Now, in addition to that, there are some of these problems that we still use today. So, and then there's some of them that they're just a good idea when you're doing long distance traveling over, say, Lake Michigan, which some of you might be able to do when you get in the Twin. So there are some formulas that are very important for safety, or just they're good to know how to do. But the rest of these, it's just purely knowledge exam. So let's take a peek. Let me skip ahead over here. So let's just kind of take a peek at the concept of dealing with angles. And that's what a lot of our formulas are dealing with, are simply angles. So if you have the handout that I provided to you, there's going to be a lot of things drawn out for you already for you to take notes on. That's great. If you didn't get the handout, if you didn't print it or don't have it electronically available, you're going to be doing a lot of drawing, and you may not catch everything that we're talking about here. So just make sure you go back and review. Okay. When we look at angles, we're going to start with the real basic 1 in 60 rule. At some point, you may have wondered, how wide is 1 degree? Your instructor may have asked you, how wide is 1 degree? And being that it's an angle that has an origin point, and as we radiate out from the source, that angle gets wider. And so when we look at an angle, we can just say 1 degree, 60 miles away, is 1 nautical mile wide. So angles get wider the farther you are from the origin point. That's why with VOR navigation, when you're far from the station, it takes longer to correct to get on center line. When you're close to the station, it goes very quickly with the needles. Same thing with the localizer concept. Same thing with the glide slope concept. And then we have a math formula here that the opposite side, which in this case is your 1 nautical mile, okay, that's the opposite, and divide that by the adjacent side, which is the 60. Okay. If you multiply that by 60, that equals then the angle that we have here. So when we prove this, we take 1, divide that by 60, then multiply by 60. you can see that the 60 times 60, those 60s will just simply cancel each other out, and 1 is going to equal 1 degree. So just kind of showing you the math behind it. This is also a tangent function. So if you're big on trigonometry, right, this opposite over the adjacent angle is a tangent function. A peek with top hat question here. And I don't know, this is going to be an FA question. We're going to do a lot of reviewing FA questions during the segment, applying every formula that we've learned. And we're going to see that an aircraft is 40 miles from a VOR station and a CDI deflection of 1/2. And that's a course centerline deviation of approximately how far? So there's your question there. Got a little graphic up there to help set it up. This is where solving for the unknown becomes a little bit more important. Well, are we stuck in park today here? Let's give you a few more seconds. X over 40 times 60 equals 5 degrees. That's how we're setting this up. All right, see how we did here. All right, 3.3 is the correct answer for that. 3.3, so we got a big variety of questions here. So let's take a peek at that. How do we really solve this one? So here's our basic problem here. This is an FA test question. We just set it up with the formula x over 40 times 60 equals 5. We've got to get 40 out of the denominator. Multiply both sides by 40. That leaves you with 60x equal to 200. Then divide by 60. So that leaves us with 60x equals 200. Divide both sides by 60. 200 divided by 60, 3.3 miles. All right, let's see if we can get this plane into first gear here. All right. All right, so that's 1 in 60 rule, and it's used for a variety of type of formulas that you could be asked about. So it's kind of the basis for a lot. And one of the favorite questions from the FA is an off-course problem. This is where an aircraft has been traveling. The pilot set the heading for the planned route, but the wind was inadvertently different than planned and blew the aircraft off course. And when the pilot got to the checkpoint, they discovered they were not over their waypoint, they were abeam it. Okay? That's the idea. So the aircraft was trying to fly along the horizontal, like call it east, if you will, and there's some sort of checkpoint down there. And the pilot discovered, oh, I am 3 miles abeam my checkpoint. So again, that's the result of wind. All right, in fact, there'd be an improper wind correction angle was the result of this one. So that means the wind was stronger from the southerly direction than anticipated. Or the pilot just simply didn't set wind correction at all. Tried to fly an east heading and got blown off course. Doesn't matter. It was the improper wind correction angle. So we're going to use the formula, which is just a variation of that 1 in 60 rule. We're still going to use the opposite side, which is your nautical miles off course, divided by the adjacent side, which is 20 miles. That's how much you have flown. Multiply that by 60, and we'll get the track air. Track air is simply the degrees of wind correction that's needed to parallel course. Right? So when we look at this type of problem, we'll set it up as 3 divided by 20. It's multiplied by 60. That's the 1 in 60 rule, and that equals our angle. And of course, this math does become a little bit easier on that. In this case, we're looking at x equals 9 degrees. Now we can simplify this formula. 20 divided by 20 is 1, and 20 divided by, or 60 divided by 20 is 3. It simplifies into 3 times 3 equals 9. So this is really what the wind correction angle should have been applied, or the additional amount the pilot should have applied. Okay? And this would simply allow the aircraft to fly parallel. Now the other part of the problem is getting back to the course. We got blown off course 9 degrees. If we simply just turn 9 degrees, we're going to parallel course, so we got to turn an additional amount, and it's called closing angle. So again, we're abeam whatever fix we had. We're still 3 miles away from that. So that's our nautical miles off course right there. And then we're going to divide it by the nautical miles remaining to our next waypoint or to our destination, whatever the case may be. Multiply by 60, and that gives us what we call the closing angle. So in this case here, we'll just simply take our 3 divided by 30, multiply by 60. That equals x. And if I want to simplify this, 30 divided by 30 is 1. 60 divided by 30 is 2. So that would give me a closing angle of 6 degrees. So the track error was step 1. Closing angle is step 2. Step number 3 for an off-course problem is to figure out the total correction to heading. And that total correction is going to be a combination of track error plus the closing angle. So just reviewing this, the pilot was intending to fly an easterly course line. Because the pilot did not apply the proper wind correction angle, the aircraft tracked away from that course line at a 9-degree angle. If the pilot simply turns 9 degrees at this point, they would simply parallel the course line. That's why they need to turn an additional 6 degrees in order to now fly to this, whatever fix this is. So the answer to this problem would be 15 degrees of heading change. In this case, it's a 15 degrees heading change to the right. So let's try a question on this, top hat. I'm going to give you an off-course problem. We're going to break it down into 3 steps here. This first one, we're going to be determining the track error. So you're 6 miles off course, and you've flown 42 miles. There's 130 remaining. So just set up a triangle on your notes somewhere. Doesn't matter what direction you want to choose, an east direction, that's fine. That's nice and simple. So we're looking at track error first. What's the effect of improper wind correction angle here? Number of miles off course divided by miles flown times 60. Oh boy, so you're still struggling with that one. A few more seconds here. All right, what did you end up getting? Most of you got the correct answer. 8.6 is the correct answer. Not sure how you got these other ones there. All right. Let's work on the other part of it. You're still 6 miles off course. You've flown the 42 miles, but you have 130 remaining to your destination there. So setting up your problem, we're setting up 6 miles or off course divided by our remaining miles to fly multiplied by 60. Doing a lot better on this one. Looks like you're starting to get it. I hope so. All right. So most of you got the correct answer, 2.8. 2.8 degrees for the closing angle. All right, so now we do step number 3. We're going to take the track error plus the closing angle. So you should already have both those numbers down. Simple addition now. Track error plus closing angle equals total heading change. Okay, 11.4 is the correct answer. Nicely done. All right, so just a quick review then. This is our setup problem. 6 miles off course over 42 miles flown, and then 6 miles off course times over, or rather divided by 130. This is how we get our sets of numbers in there. 11.4. So that's typical FA test question. And you'll most certainly see an example of each of these questions on your exam delta. That will be a couple weeks after spring break.